Welcome to 4-7 negative exponents, where our two objectives are to write expressions using negative exponents and evaluate numerical expressions containing negative exponents. Two methods that have been covered in the past are quotient of powers and definition of powers. As you can see in our example, in method number 1, we of course subtract our exponents and come up with a negative exponent. In the definition of powers, we use our factorization skills, cross out, and we notice that we have 1 over x squared. Two different answers, two valid methods. So since we have x cubed divided by x to the fifth cannot have two different values, you can conclude that x to the negative 2 power is the same thing as 1 over x squared. Now that we learned that there's two ways that negative exponents can look or be written, we need to deal with negative exponents. In algebra, we do not use them. We use them in certain situations like scientific notation, but right now we're going to learn how to deal with a negative exponent and change it into a positive. So let's look at our example here on this page. We have 5 to the negative 4th. So what I'm going to do is I'm going to build myself a fraction. I'm going to take everything. I'm going to take my base and my exponent and put it in the denominator. That automatically changes my negative into a positive. Now we're going to deal with the numerator. What happened to the numerator? Well, remind ourselves, this is a multiplication here, so there's still a 1 there. So that, ladies and gentlemen, is the basics, or the key concept for negative exponents. Let's look at two examples when we write each expression using a positive exponent. So we see here, we have 6 as our base, and we have it raised to the negative 2 power. We cannot have a negative exponent. So what we're going to do here is we're going to take our base and put it in the denominator. Along with it, our exponent's going to come with us, and as soon as we go to the denominator, it changes to a positive. Now let's talk about the numerator. What's there? Think of it once again as a multiplication, that invisible number that we multiply every number by, and that's 1. Is this true for variables? Yes, it is. Notice that we have a base of x in question B, so I'm going to make a fraction. I'm going to take my base and put it in the denominator. My exponent follows along and changes to a positive. And once again, our numerator stays 1. On this page, we have write 1 over 9, 1/9, as an expression using negative exponents. Well, there are no exponents in this fraction. We're going to have to definitely do something. So let's write 1 over 9. Let's use some of our prior skills. We're going to use prime factorization, so we're going to change this to 3 times 3, and that's the same as 9. 1 will stay 1. There is no prime factorization of 1. Now let's go ahead and rewrite this with an exponent. So this would be 3 squared. Now we do have a positive exponent, but we want to use a negative exponent. So what are we going to do? We're going to continue with our fraction. We're now going to move our base up to the numerator along with our exponent. And since it was positive, now that we moved it up, it now becomes a negative. And that's over 1. Now let's go ahead and simplify that, because anything over 1 is just itself. So there's our answer, ladies and gentlemen. 3 raised to the negative 2 power is the same as 1 over 9. Write each decimal using a negative exponent. What we have here is a decimal for sure. And what we're going to do is some major rewriting. First thing you're going to learn is that we're going to use 10 as our base. Always going to use 10. First off, we want to know what number our exponent is. So we're going to move our decimal until we get a whole number. 1, 2, 3, 4. It took me 4 spaces to make this a whole number. So there is my exponent. Our next question is it positive or is it negative? Well, if you remember back when we did scientific notation, we have our old decimal and our new decimal. New to old went left, and left is always negative. So that tells me that this is a -4. We can see something like this type of problem in a science course, biology course. So you're going to see a mix of concepts used in your science classes with math. Here it is. A molecule of water contains 2 hydrogen atoms and 1 oxygen atom. A hydrogen atom is only 0.00000001 centimeter in diameter. Write the decimal as a fraction and as a power of 10. Okay? All right, let's deal with this situation one at a time. Let's do power of 10, what we learned in the previous slide. Power of 10 means that my answer is going to have a base of 10. I'm going to count how many decimal places it takes for me to make this a whole number. 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is 8. This is my old. This is my new. I went to the left. Left is negative. Now, how do I write this as a fraction? Okay. Well, that's just the rule that we've learned, that we cannot have negative exponents, so let's change it to a positive. I'm going to take my base, 10. I'm going to bring my exponent, and because I put it in the denominator, it changes positive. And on top, since it's multiplication, we also multiply by that 1, and that's why we have a 1 there. All right, in this slide, we have evaluate. N raised to the -3rd power if n is equal to 2. So this is an evaluate. We are going to plug and chug. So wherever there's an n, we're going to put 2. So here we go, 2. And that's going to be raised to the -3rd power. Once again, I put it inside parentheses. That's good practice. Now, what can I do here? I cannot say 2 to the 3rd power because of the negative sign. This negative sign prevents me from doing that. In order to evaluate this, I need to have a positive exponent. And we learned that we're going to just build a fraction. 1 goes on top. The 2, the base, goes on the bottom, and the 3 turns to a positive. Now we can evaluate, now that it is a positive exponent. It's 1, and 2 to the 3rd power is 8.